Okay, I'm here. And I just had to reboot everything. That happens once in a while. Not sure why. So just do it. I rebooted. I wanted to show you here on the course website. In the section, how do I get rid of this? This is a very strange, this is in Safari. I probably should have opened in Google, would have made a difference. But you can see here what I want to show you. I don't know if I can show you. It's very delayed. So what I'm going to do with the schedule is next week we're going to, the mock exam is up. It's been up the whole semester. But I'm going to, next week I'm going to review it in depth, but I'm going to ask you to complete it before Monday, okay? And then I'm going to post the solutions to it on Sunday night so you can actually review before we meet on Monday and have an idea if you did it wrong or right. The idea of the mock final is that you attempt the exam by yourself. And the mock exam is in the same distribution as the final exam, so it has the same number of questions, or I guess the same percentage worth of problems from the different units and the different components, because there's 8, right? We have 8 components to the course, 8 modules. So what I want to do, I wanted to use this pantalla to solve these problems, but I'm going to end up just taking a picture and using, I don't know, it's going to be a little more involved. Let's, oops, maybe I'll do these, I'll solve these on Monday because I didn't set it up properly and I wasted a lot of time trying to reboot my machine. I don't know why I can't get this off. This usually goes away. Anyway, so there were the quiz questions yesterday. I'll do them. I'll solve them tomorrow or Monday. I'll just put the, I'll solve them for you. And if you have any extra questions, send them along for Monday's class, relevant to the mock exam or any of the material. So what you have to do in your studying, be aware that I've posted what I call the approximate exam distribution. And I put it in, I don't know why I can't maneuver in here. Okay, so I put it in here. Not there. Here. That's the approximate exam distribution. There it is. Alright, so you're going to have, in terms of proportion of value for the different components of the course, it's going to be 40% weighted for inference. And I've guided you on what you don't have to worry about. So you don't have to worry about hypergeometric Poisson, continuity correction factor. You can omit the pages on 2-sample t-tests and the different kinds of tests in chi-squared. So just follow along here. I said there's going to be 16 multiple choice questions, 5 short answer questions, where you choose 5 out of 7. So you'll get the idea when you do the mock exam what to expect. So there's no real surprises. Get through my notes and you will be prepared. You still have time, all right? Remember, you get to use all your resources, but don't depend on them. Understand your notes. Work with the formula sheet and put extra notes. Add them onto your formula sheet or rewrite the formula sheet. However you prepare an outline to study and to write the exam, make sure you do prepare. To use this opportunity to prepare yourself so your notes are organized and at least you're working off a few sheets of paper rather than all of the hundreds of pages of notes that you have and videos. 70 videos in the course, and then I did the additional, I don't know how many, 40 videos or so? Maybe I'm overestimating. Anyway, there are a lot of videos, so a lot of time, a lot of hours. Organize them. That's going to be your, that's going to be the best strategy. Okay, it's about content, sure, but organize all this content. So what I'm going to do now is I'm going to solve some problems, other problems. I'm going to, since nobody sent me anything, and you have the quizzes online to work with, but you also have some other review exercises. I'll do some old exam questions. So I'm going to present the question. I'll give you 5 minutes and then we'll regroup, okay? So these, you've never seen these before. I don't think you've seen many of these. This is where I'm pulling the quiz questions from too. They're just old final exams. So I'll just pull some out. See, that's the one we did the other day. Oh, I better choose this. Hello, everyone. Nice to see you. Any comments on the quizzes while I'm loading this up? Oh yeah, I like this one. So I don't know if you saw this problem yet. Let's try this. This is going to be probability. So let's do some things in order. Let's do a probability problem. See how long this takes us. That'll move us into the binomial and SDS. And then we'll focus completely next week on inference, unless you have some more problems that you'd like me to try for probability. So why don't you try this exercise? Set this up. I'll give you 5 minutes. Okay, let's see if 5 minutes is enough. Okay, we'll check back in 5 minutes. Just to reiterate, you don't have this anywhere, I don't think, in the notes. This is these are extra problems, and I will. Well, they're in the videos here that I'm making. Maybe I'll put them. I'll post them in the Moodle page as well. So to solve this, you should be drawing a Venn diagram. All right. Okay, that was 5 minutes. How did you do? How did you do? What you need to do is, you need to draw this. And that's going to be a real mess on here, but I'm going to guide you. I'm going to guide you as much as I can. So you're going to make a Venn diagram. Maybe I can use colors. So wine will be red. Wine is 55%. And then beer, blue, will be 40%. And then beer and wine will be the overlap part here, which will be, let's try a different color. What is it? It's 22%. And then what happens? And then wine and vodka. So yes, vodka. Now I'm going to introduce vodka is black. Vodka. Wine and vodka. So presumably this crosses over here as well, right? So all three. So wine and vodka, which would be the red and the black, is 6%. %5 for beer and vodka. So beer, blue for beer, and vodka is going to be 5%. And I think this is a huge piece of information. 50% will be beer or vodka. So that is all of this is beer or vodka. 50%. That even crosses over here. So, and then all three of them, the overlap of all three of them is this little center in here. The center piece will be that, 2%. So you're going to draw this. You're going to draw this. And then figure out the answer to the question of how many people bought vodka. So what you really want is to sort out the black part. I mean, just the circle for vodka, right? So what do you guys get? Caroline threw it out there. She gets 0.29. Anybody else? So that is not the right answer, Caroline, but it's a good try. So something went wrong in your calculation. Now I'm not going to, let's say, what do I tell you? What if I tell you the answer and then you guys can check what you did wrong? But it's just a matter of being diligent and neat about drawing this and realizing, you know, this is a really key point about the 50% beer or vodka. So that all of that and that are 50. You just have to be careful about the double counting. So this little space in here is 22, but yes, this whole thing between them is 22. This thing between those two is 6, and between those is 5. But because they all overlap and they share this common piece, you don't want to double count that piece, right? So that's why they give you the 2%. So you have all that information. Anybody else get another guess? No other guesses? Don't want to tell you. I want you to figure it out. Okay, the answer should be 15%. Now notice my drawings are not really to scale. So don't let that throw you off, that the answer for vodka should be 15%. So, and like this space in here should be much bigger than these. But if you want to worry about that, maybe that'll help you too if you draw it to scale as best as you can. But you're going to have to redraw and redraw it. Yes, 15%. Very good. Caroline's got it. So that's the answer. So try that. If you don't get 15%, send me your work and I can help you out. But that's what you should be getting. So I'll post these questions, ones I choose to look at, in the Moodle, on the Moodle page. So there's a bunch more. Maybe I'll just put them all up there for you with the answers. Okay, so you can try those. So much more, because you invest a lot of time in solving, in drawing the Venn diagram. Might as well use it for several questions. Actually, it's used for 5 questions, 7 to 11, in this exam. So I'll put those together for you. All right, let's do a bin problem. Let's see if I can find a bin problem. Okay, what about number 10? It's actually part of this. Number 10. In a random sample of 17 customers, what's the probability that exactly 10 of them buy wine? So that is binomial. That's a binomial problem. You have to identify X and P and K. So I will give you 5 minutes for that, okay? So I want you to find X, N, P, and K, and then solve for the probability. All right, 5 minutes. Delia is asking me about the structure of the Venn diagram. Venn diagrams are usually in circles. It's probably more intuitive to use circles. I'm trying to think if there's any problem with using squares or rectangles. No, there isn't. There's nothing really I see except you have the corners and it can just get messy, I guess. overlapping squares. But yeah, you could just as well use any kind of shape, right? It doesn't even have to be a circle. So anyway, continue with this problem. So if you finished number 10, what about number 11? Go on to number 11. Let me know if you got the answer to 10. I'll give you another minute. That's right, Caroline. That's what I get to. I get E. So what you're doing is you're reading the problem, you're identifying if it's a binomial problem, so you can use the formulas from number 1 on your formula sheet. In that case, you would have to be able to see what X is, what N is, what P is, and what K is. The thing is, the success that we're looking for is a customer buying wine. I have that probability, so this is my little P. This is actually my P, right? The true proportion of people who are customers who buy wine. So that's going to be 0.55 here. Then the number of times I'm going to look to see if a customer buys wine is 17. So the possible outcomes of looking at 17 people to see if they buy wine is it's either going to be 0 or 1 or 2 all the way. Sorry, I'm going to do this. This is hard to read. I'm going to do it above. So when you list the x's, right, the possibilities for x can be a 1, sorry, not 1, 0. Starts at 0, it could be 1, it could be 2, it could be 3, it could be 4, all the way to possible 17, if you guys can follow that. Those are all the possibilities for x. So then all I have to do is calculate for 10. So I use the formula for 10 customers. I'll make it big again. And the formula would be for a k of 10. So x equals k, right? Then the formula is 17 possible customers who buy wine, but I'm only interested in exactly 10. So the chance of actually buying is 55%. So 10 are going to buy, so that's successes to the number of successes. And then failure to the number of failures. If there's 10 successes, that leaves 7 failures. So that's what I plug into my calculator. Use brackets, practice entering this. To enter this piece, remember it's 17, well it depends which calculator you have, but 17 second function NCR 10 and then times and the rest of the terms. So any questions? That's straightforward. Once you get a few of those, you get the hang of it. Remember, I have all the solutions up online for the probability homework. I also have all the solutions online for all the homework, for the normal homework, for all the homework. So you guys should check out those homework solutions. If you have any questions, just keep doing problems or ask me. All right, so the answer was E. When you plug that in, you get 0.1841. I went too far up into this other problem, but anyway, that's the result. All right, I said try 11. So I'll give you 5 minutes for 11. It's about, this is now an SDS problem. How do I know? Because it's sampling distribution of the sample statistic, or the sampling distribution of the statistic, and the statistic here is is about proportions. So this is for p hat. The sampling distribution of a statistic, and that statistic is p hat. So you're looking at formulas number 2 on the formula sheet. So for that you're going to need your p, where p is the number they give you, 0.38. No, sorry, not 0.38. You have to look at what we're interested in. In this question, number 11, we're interested in buying beer. And beer, I used blue. So I'm going to, for buying beer, the probability of buying beer was what? I have to go back. The probability of beer was 40%. So that was 40%. So it turns out to be 0.4. So with that, knowing that I want to answer a question about the sampling distribution of the statistic in a random sample, that's how I know. In a random sample, what is the approximate probability that less than? Okay, so I'll give you a couple minutes and I'll check back with you. Tell me which one is the right answer. I'll give you 5 minutes. Okay, so this is where you're headed, right? You're going to use formula 2 on the formula sheet. You're going to verify that n times p is greater than or equal to 10, and that's going to be 12. Is that not right? $120, sorry, I'm always messing up those zeros. That's 120, and so that's definitely greater than 10, and then n times 1 minus p will even be larger, so those are greater than 10. So that satisfies the condition, and we have to assume that the population is large, and it satisfies the condition so that x is approximately normal with a mean of n, well, we're going to use proportion, so we want to do this for, not for x, sorry, I'm going to go back. I'm going to do this for p hat, right, because I want to know about the proportions. The proportion, p hat, is approximately normal with a mean of p, which is given as 0.4. And the calculation that you have to make, this is just copying, the calculation you really have to make is for the standard deviation. Standard deviation is going to be calculated as p. Okay, I'm getting messy, aren't I, with this? I'm going to make this bigger. So you want to calculate the standard deviation using the formula. I'll put it here. It's going to be p times 1 minus p over n square root, and if you don't remember where we got that from, go back and look at the videos. We derive that, and whatever you get for that, you put in here. So tell me what that number is, and I'll put it in there. What's this? 0.4 times 0.6. Right, so I always, I don't usually copy this formula repeatedly. I just put the value down and then its complement right beside it. Just faster that way. And that's right, it's 0.0282. Don't forget the square root. Got it in? Or are you answering the whole thing? You're giving me the final answer. Okay, so for the standard deviation, 0.4 times 0.6 divided by 300 square root. So this is 0.283. I'm going to round, right? I told you for the probability stuff, for bin, that's what you do. You use 4 decimal places. And now I answer the question. I have my distribution, and now I can answer any question about predicting what p hat will be. So I want to see, is it less than 38% of them? So I solve probability that p hat is less than 38, and I solve using the probability distribution, the density that I derived using the theory. All right, so I standardize this, and Caroline's telling me that she gets the answer D, I guess. I'm not going to do the rest. I want you guys to do that because that's tedious at this point. You guys should be able to do that though, because that's a tool you already learned. And this is question 11. Yeah, the answer is D. So the answer is, for this one, D. So you should be able to do that. So we've done a bin, we've done SDS, we did probability, we've done a lot. We don't have too much time, but I'm thinking I will just do, let's do something that's confusing. And maybe I'll leave you 3 problems that you can prepare for Monday, okay? I won't tell you the answers. So let's see. Inference problems for Monday. Okay, what I'm going to do is, there's the one I gave you yesterday. So I said I would answer those, or I'll give you, I like to prepare the solution for those ones that I gave you yesterday. I just didn't, I got messed up at the beginning putting it up on the screen. So, so let me prepare these for you. I will give you these problems for Monday so you can do them for me, okay? And these are all about inference and hypothesis testing. So allow me to do that. I'm going to prepare some exercises and I'll say just due on Monday. And when we get together on Monday, hopefully you can be there. Or if you're not, just send me a message in advance and make sure, that way I'll be sure to answer it in the video and you can watch it later. All right, so I'm going to sign off. I kind of feel like doing this one. I'll just do this one before we go. And I did start 10 minutes late, so let's see if I can do this one. This is the one I put up for a quiz yesterday. Variable x is described by a semicircle density curve with a mean of 0 and standard deviation of 0.4. We take a simple random sample of 100 people and from this distribution, and we can calculate a sample mean. What do we know about the sampling distribution of x bar? So the formula you're going to apply there is the third formula on SDS for the sample mean, right? And basically, here's my n. So n is 100. And so I'm told the mean here, mu, is equal to 0, and sigma is given to me. So this is the information. Again, you have to separate out the population information from the sample. This is all about the density curve. Information from the density curve is population information. Okay, that's everything. That's everyone. It's all the possibilities. So the mean is 0, and the standard deviation, or sigma, is 0.4. It's very messy, isn't it? So 0.4. So those pieces of information, I have to figure out the sampling distribution. The theory from number 3 tells me the mean will be the same, so it has to be 0. So the mean of the new distribution, and you know, that's what I use for notation, but don't let it confuse you. That's the new distribution, the sampling distribution of x, the sample mean. So that will be 0. The new standard deviation will be computed by taking the original one and dividing by square root of n. So your answer, and the shape. The question is about the shape. What will the shape be? So those are the 3 things. You got to find the new mean, the new standard deviation, and the shape. So you need to compute that. What's sigma of 0.4 divided by square root of 100? So 0.4 divided by square root of 100. Square root of 100 is 10. So 0.4 divided by 10 is 0.04. So that narrows my possibilities, right? So for 0.4 as the standard deviation, if I look at my options, that's going to be B or E. So, which one is it? B or E? By the theory, since the sample size was 100, that was sufficient for E to be the answer. Approximately normal. So the sampling distribution, because I sampled a large enough sample, it's much more stable and closer to the true population mean mu, and that exhibits as a normal, regular, more predictable distribution, and that's why we say it's approximately normal. Well, we say that we actually test it empirically to determine that, but that's where that comes from. All right, so I will stop there and put this stuff up and see if I can. I'll prepare a document with the quizzes so I can solve them on Monday with the questions I'm just going to post, so we can have a very robust lesson on Monday. So work this weekend on preparing the mock final exam. You have enough, more than enough to work with, and we can talk about your deficiencies after solving these problems on Monday, and then on Tuesday we'll just continue until the test on Thursday. Let me know if you have any questions or any things you want me to focus on. But pretty much next week I'm going to focus on the inference unit. Okay, good night.